Hello.
Hey,
How are you?
I'm good. How are you?
I'm good.
Okay, let me pull up. Well, share my screen. One of my friends told me she contacted you.
Yeah. I contacted.
Mhm.
I responded. Thank you for that.
No problem. Yeah, she's in my whatchamacallit. We're in the same program.
Got it.
Yeah. But she's taken it once only
Yeah.
and got like a 4.99, but
Mm-hmm.
so close.
Yeah.
Let's
I
see.
think I'm seeing her on Wednesday.
Oh, okay. So I finally, let me show you. You'll be
Oh,
proud.
nice.
I finally broke a
500?
125 on the cars.
Oh, nice. That's awesome.
You don't know how happy I was. Oh my God. I was like, wow,
Mm-hmm.
it's great. But
Congrats.
I did start reviewing the CP and BB section. Well, I've already reviewed it. So
Yeah.
I'm just going to ask you the few questions that I still,
Mm-hmm.
that's how I know I don't remember
Mm-hmm.
question because I get the same ones wrong or
Yeah.
I'll get something wrong that I got right last time.
Yeah.
So, okay.
Do you get I think you told me once that you get like extra time. Is that true? Like on the actual test?
You said I get what?
Do you get like time accommodations or something?
I'm supposed to, but that's only if I like request it and I
Yeah.
have to like submit paperwork. And so I didn't feel like doing all of that.
Got it.
But there's this girl that's, she's a year three medical
Mm-hmm.
student. Well, she's going into her year three and she gave me some propranolol because she takes it and I was telling her how I think I have testing anxiety. Well, I
Uh-huh.
know. And yeah, she gave me that, and I think that's what helped me, honestly.
Oh yeah. It's a beta blocker,
Yeah,
so
I
it
have.
blocks the beta adrenergic receptors, so it calms you
Mm,
down.
that's good because, and I was like, I'm gonna ask my psychiatrist for it because
Mm-hmm.
it helped me. Let me see. Where is this? Right here. Okay, here we go. So this question, right?
Mm-hmm.
And I think I got this one wrong last time too. So I know the equation is Hc over wavelength, but when we're talking about like the whole fluorescence thing, it said up here, this. So it said up here that I don't get the whole emission and then excitation. Like,
All right. So it's like remember that question that we had about whatever lobsters.
yes. And I don't
So
understand it like that there either.
oh okay. So basically, what happens with a pigment or something like that is so you remember how when we went over like so for like a regular atom, if you
Mhm.
shoot light, shoot a photon at it, it'll absorb the energy of that photon and it'll cause an electron to go from its ground state to its excited
But
state.
yes.
And then when it relaxes back from its excited state to its ground state, it emits a photon of equivalent wavelength or equivalent frequency. So
Mm-hmm.
that's for like a regular atom, right? Now the thing with pigments and chromophores and things like that is that when it absorbs a photon,
Mm-hmm.
um, and its electrons go to an excited state, it
Mm-hmm.
has those conjugated pi, double bonds,
Mm-hmm.
which gives it resonance stabilization. So it's able to be stabilized in its excited state. So
Mm-hmm.
that means that when the electrons go from their excited state back to their ground state, they emit a photon of
Mm-hmm.
lower energy
They'll emit a photon of lower energy because
Yeah,
what now?
because of resonance stabilization. So normally, it'll
Okay.
absorb a photon
Mm-hmm.
and emit a photon at the same exact energy level. But
Oh.
a pigment or a chromophore or thing like the thing in this whatever
Mm-hmm.
passage, it absorbs the photon and
Mm-hmm.
it emits it at a lower energy level instead of an equivalent energy level.
Okay, so
So
that
that's
makes
why,
sense. But
yeah.
when you're doing the calculation, how do you know to do the 360 minus
Okay.
440?
So if you go back up, I just wanted to show you. So it says that it gets excited at 360 nanometers, right? But and that
That's
means it's a
when light
higher.
first come hits and the
Mm-hmm.
electron goes from ground to excited.
Mm-hmm. Yeah. So
Mm-hmm.
it gets excited at that energy level, which is the wavelength of 360 nanometers.
Mm-hmm.
But it emits a photon at 440 nanometers, which is a lower energy photon.
Yeah.
Okay. So
Mm-hmm.
so okay, let's look at the question. So okay, energy in joules per photon. Okay, so they take Planck's constant and they multiply it by the speed of light,
Mm-hmm.
and then you divide it by the uh, the wavelength. Okay, so let's see. Oh, all right. So instead of dividing, they're multiplying it by its reciprocal. You remember you can
Yeah.
do that, right? Okay. So
So
now,
I'll start that part. I think okay.
yeah.
So 440 is because I know energy and wavelength are inversely proportional. So if it has a higher wavelength, lower frequency. So when they're talking about it being converted, I guess that's how I should have known to.
Oh yeah, so they're doing the difference between the photon that it absorbs and the photon that it emits.
Got you. Okay. Let me. I'm taking notes at the
Mm-hmm.
same. Let's see. Phone to. Yeah. Okay.
Yeah, the way that they wrote it out, it looks a little confusing,
Mm-hmm.
but it's really just like 1 over 360 times 10 to the ninth
Mm-hmm.
minus 1 over 440 times 10 to the ninth.
Okay. Let me see. This means right here. So with chromophores and like pigments, you said, well, is chromophore is a pigment, right?
Mm-hmm.
So you said with pigments and what else?
Oh, like pigment slash chromophore slash, things with lots of conjugated pi double bonds. And they're asking for the energy, the light energy that is converted to other forms.
Mm-hmm.
So basically, since it absorbs, like, it absorbs at the 360, since it absorbs at 360 nanometers and emits at 440 nanometers, the difference between the two is the energy that's converted into another form.
Got you. So they'll excite at a certain wavelength and
Yeah, you could say they'll excite at a higher energy level than that they emit.
higher. But with regular electrons, like I guess single bonds, it excites it at the same, excites and emits at the same energy level.
Mm-hmm.
Okay. Give me 1 second. Sorry. I need to grab a fork. Okay. Okay, that makes sense. My next one is number 12. I hate this one. So for this one, I chose C because I don't know. I was just trying to make sense of it.
Oh, okay. So energy is always conserved. So you're never gonna have anything like you can change the force, you can change the distance, but energy, which is force times distance, right? Or really displacement, maintains that same energy level. Like in machines, you'll see examples of
Wait, energy is force times distance? I thought it was.
it's force times displacement cosine of theta. It's the work energy theorem, so I'm doing
Gotcha.
work.
So work equals the same thing as
Yeah,
same.
because energy, the definition of energy in physics is the ability to do work.
Mm-hmm.
And work is force times displacement times cosine of theta.
Mm-hmm.
So, aka force, when the force and the displacement are parallel to one another.
Mm-hmm.
So, yeah, so in examples of machines, like an inclined plane.
Yep, that's mechanical advantage, right?
Yes, yes. Mechanical advantage is basically the advantage you get from a machine. So the
Gotcha.
machine can be like an inclined plane. It can be like a pulley. It can be a lever,
Mm-hmm.
right? And so basically, like an inclined plane, if you bring something like if you just pull something straight up,
Mm-hmm.
like along the height of that inclined plane, then that energy or work is equivalent to rolling it up like the inclined plane, like along that incline.
Mm-hmm.
So the energy and slash work, that is conserved. That's exactly the same. But since it's equal to the force times the displacement, if you increase the displacement, it'll
Mm-hmm.
reduce the force that you need.
Okay. Gotcha. Okay. That makes sense.
Okay, so for this one, so that's just like how you know that C won't be it.
Mm-hmm. And
Now
I
there's gonna be like, okay, wait, what was that?
yeah, so I just didn't. Oh, now that you're telling me the whole energy is same, kind of the same thing as
Mm-hmm.
work, or as the ability to do work.
Yes.
And if you increase force, that deals with the displacement being lower, right?
Oh, if you increase force, displacement will be lower, but you want to make the force lower most of the time, so you will
Mm-hmm.
increase the displacement.
Got you.
So like, if something is on like an inclined plane like that, if you bring it just straight upwards,
Mm-hmm.
that's like the energy, right? Or the work required going like
Mm-hmm.
up the height of an inclined plane, but the along the plane, it's a longer
Mm-hmm.
distance than that height. And if you increase the distance, then since work is conserved, aka energy is conserved, then the
Mm-hmm.
force will have to go down. There's like
Okay.
it's kind of like so like they're not, I haven't seen any questions on momentum, but with momentum, which is
Mm-hmm.
basically, or um I think it's called impulse, which is a change in momentum.
Mm-hmm.
That equation is force times time.
Force
And
times time.
so like this is how an airbag works, because
Mm-hmm.
the change in momentum for that case is equal to the average force over time. I mean, sorry, average force times time.
Mm-hmm.
So if you increase the time, then that force that you experience is lower. So an airbag basically works by, like, when you like get into a car crash or something, like God
Mm-hmm.
forbid, you feel like you can't change that change in momentum, but you can change what you feel, because what you feel is the force. But if
Mm-hmm.
you so with an airbag, since like it is like a balloon and it kind of takes longer for you to for your head or whatever, your body, to
Mm-hmm.
spread that force out
Mm-hmm.
over like a period of time. If that period of time is longer, then that force that you experience is lower. So that's just another example of this type of like inverse proportion over here. So let's see. Why must the person either lean forward or slide their feet under the chair in order to stand up? Okay. So if you lean forward, your like upper body, like where that black dot is. So you see there's like these like,
Right.
yeah. So like the one black dot that's up above it, yeah. So if you lean forward, that's gonna go in line with the white dot that's at the knee.
Okay.
So like, show me where it would go then.
You said if I lean forward, this
Mm-hmm.
dot will go over here.
Yep. So that's one thing that could happen, right? And then if you slide your feet under the chair,
Mm-hmm.
then basically like they don't have like a dot, but imagine there's a dot like at the base of the foot, like at the heel.
Right here.
Yeah, at like the heel.
Oh, okay.
Yeah. So that's in line with the knee, right? Now, if you if you slide your feet under the chair, imagine that going like down in line with that black dot at the hip.
Mm-hmm.
Yeah.
Okay.
So that's basically like, it's basically to like that kind of stuff is just basically to keep everything in line.
Mm-hmm.
So it keeps the body at equilibrium. That's kind of
Okay.
like how I would describe like if you were to do an exercise like a workout like a squat,
Mm-hmm.
because most people they do. So wait, so do you have access to the OneNote that we used to use?
Yeah, but only the online version.
Okay.
Can we
Um,
start a new one?
what's that?
Can we start a new one? I could
Yeah,
start or
yeah, I could do that. Here.
only because I want it to like I don't want to confuse like
Mm-hmm.
the
Okay.
I did last time.
Here. Whoops.
And I think do you remember the email I gave you?
Um.
It's DI and then
Oh,
DI.
here. Let me make. All right. What was it? D I
D DIALLO
A
again.
L L O.
So
Just D
did
I A L
DI
O.
first and then DIALLO.
Here, you can write it in the chat. Is it that 1997 at Gmail one? It'll have to be whichever one that you have your OneNote like account.
Yeah, that's the one I'm
Oh,
about to
got it.
give you.
Okay.
Oh no.
Oh, okay, got it. Okay. I shared it.
Okay, I'm waiting for the notification. Mm. I don't know why it's taking so long to come. I'm still waiting on notification. That's why I haven't opened it. Because I'm supposed to get like an email, right?
I think so. Yeah. Right. Like, see if you can refresh your email account.
Yeah, I refreshed it. I don't see it. Oh, what the heck? Ow. Right. Do you want to just move on to the next one until I get it?
Yeah, we could do that.
Okay, the next one is 56. So I still kind of have a hard time with half-life. I mean, I got this right, but it was...
Okay, so let's look at how long it took for a 75-year-old male to walk one lap. 75, okay. Time to walk 5 laps is 200 seconds. Yeah. So we divide that by 5 and we get 40 seconds.
Yeah. Okay. So I knew how to get to that.
2 half-lives happened, right?
Say it again.
So after 40 seconds, 2 half-lives happened.
Okay, so that's where I start to get confused because the way I usually set it up is I put the half-life on the left and then the seconds or whatever on the right. And on the left under half-life, I'll put 1, 2, 3 or whatever, or 0, 1, 2, 3. And then on the right, I start with the starting material. So I would have started with the 40 seconds and went down till I got to 20 seconds. So that would have been...
Oh, just think of it this way. So 40 seconds is how long it takes. So find out the total time, which is 40 seconds. And then you can like either divide the time it takes for a half-life to occur into that, or you can just count like using your fingers. Like that's kind of like what I do. So after 20 seconds, I know 1 half-life has passed. After the next 20 seconds, aka 40 seconds, 2 half-lives have passed. So in 40 seconds, 2 half-lives have passed. So that means that like after the first half-life, 1/2 of that material is left. After the second half-life, 1/4 of that material is left.
Okay.
How much of the material would be left after 60 seconds?
That's 3 half-lives. 1/2 to the third power, right?
Oh yeah. Which is
75%.
Wait, what? What's 1/2 to the third power?
Is 0.5. No, 1/2 times 1/2 is 1/4, and 1/4 times 1/2 is 1/8.
Correct.
Um,
And
that's-
1/8 is 0.125.
yep.
And then if you multiply that by 100, it's 12.5%.
Okay. I just need to do a lot of like half-life problems because I always confuse them when I'm doing them.
Okay. But yeah, you can do it that way. You can do it like, so I guess they use the formula with 1/2 to the n
Mhm.
power, and n could be the number of half-lives.
Mhm. Okay. Mm,
Let's see. Okay. Which of the following energy conversions best describes what takes place in a battery-powered resistive circuit? Okay. So it's powered by a battery, right?
So question, when
Yeah.
we because I know when we were going over this last time,
Mm-hmm.
so galvanic cells are considered batteries, or is that
Yes.
electrolytic? So yes, that's what I was thinking. Galvanic cells are considered batteries. So I thought galvanic cells produce
They do.
electric. So that's why I
They
chose B.
produce electrical energy from what energy?
Chemical.
Correct. So, so, um, so you wait. So then it should start
Oh,
off with chemical to electrical, right?
I just thought I
Oh,
looked at the answer choice that had
the in
electric as
between.
the last
I see.
one.
I see. So it's battery powered. So that's where the chemical to electrical happens within the battery itself. But
Mm-hmm.
the battery is attached to a circuit that has a resistor to it, and resistors they cause basically heat to be released.
Okay.
So
Let
as
me.
as electricity runs through the resistor,
Mm-hmm.
it's dissipated as heat. So
Okay.
thermal energy.
Okay. So that means
What's the energy conversion for an electrolytic cell? What type of energy to what type of?
opposite.
So,
Uh, what is that? Thermal to electric to
oh,
chemical.
so thermal, that part is just because of the resistor,
Mm-hmm.
but
So
just for,
uh,
yeah,
it'll produce chemical
from,
electric
yep,
source.
yeah. So, yeah, basically the battery itself is
Mm-hmm.
where the galvanic cell is.
Mm-hmm.
And if a battery dies, like, for instance, like battery in your phone, battery in your computer,
Mm-hmm.
like that's all like, some type of galvanic cell within. And when that
Okay.
battery dies, right, because
Mm-hmm.
everything wants to go to equilibrium,
Mm-hmm.
you're going to have to plug it in to charge it, right?
Yeah.
So that's when you have an external electric source of energy that is converted into chemical energy to make that battery like have its charges separated again.
Okay.
So
That
like,
makes.
yeah. So like for a lithium ion battery, right?
Mm-hmm.
That's like the battery type for most like cell phones and computers,
Mm-hmm.
laptops and stuff. It's a concentration cell. So basically there's a higher concentration of lithium positive ion at one end
Mm-hmm.
and a lower concentration of lithium ion at the other end.
Mm-hmm.
And when you attach like a wire or you put it into a circuit from one end
Mm-hmm.
to the other end, electrons move from the part that has a greater concentration of the positive ion to the one that has a lower concentration. And
Mm-hmm.
so when an electron goes to a lithium positive ion, that turns into just regular neutral lithium, right?
Mm-hmm.
So after like enough time has passed, the lithium ions will be completely neutralized. That's when equilibrium is reached, and that's when the battery is dead.
Okay.
So it starts off with a greater concentration of lithium ion at one end and a lower concentration at the other end.
Mm-hmm.
And with each electron that moves through, right,
Mm-hmm.
they become closer and closer. There's less of a charge separation. They become closer and closer until they're equilibrium. That's when the battery is dead. And that's when you plug it in to an external source of electrical energy. And your electrical energy causes the lithium ions or the lithium neutral atoms to ionize and create that charge separation again, where there's positive at one end and negative at the other.
Okay. That makes sense.
Mm-hmm.
So when I was doing MEMS, hold on, they brought up this other type of because I know about galvanic and electrolytic, but it confused me when I saw this. A concentration.
Oh yeah, that's what I was talking about. Concentration cell is just the same thing as a galvanic cell or a voltaic cell, but instead of it being between two different types of metals, you just have one metal. So lithium-ion battery is an example of a concentration cell.
Okay.
And see how it says movement is driven by concentration gradient?
Yes.
So gradient means differential, like a difference. So that's the difference in concentration. So if you scroll down, they probably have a picture of one. I guess they don't.
Oh, not of the concentrated. Oh, they have this one.
Okay. So, all right, they don't have one for a concentration cell, but basically, well, I drew one in your new notebook, but let me see if I can find.
And it said concentration is between one ion, and galvanic and electrolytic is between two.
Oh yeah. Well, yeah. But think of a concentration cell as being like another example of a galvanic cell, in that, here. Here, I'll post this image link in the chat.
Okay.
Oh, here, wait. The second one that I post, the second link is better. Alright, so see, this is a concentration cell. So it works along the same principle that a galvanic cell, aka voltaic cell, works. In that, it's a spontaneous, chemical energy to electrical energy. So, but it's just one type of metal. And the difference is, instead of like regular galvanic cell, you have two different metals with one having a higher reduction potential than the other. Here, you just have one metal, but a higher concentration at one end and a lower concentration at the other. So you see how there's the anode and the cathode? Okay, so basically... and then there's a separator over here. So basically you have So yeah, you basically have at the cathode you have like a more of the lithium ions, and at the anode you have fewer or less. And during like the discharge. Here, hold on. Let me see if I can find something that doesn't have it connect. Here. Okay, here, this one's much better. One sec. All right. Try this one. All right, so this is better. So, because basically, so all right, this is the same thing, but we have essentially like a circuit
Mm-hmm.
or a wire connected from the negative end to the positive end.
Mm-hmm.
So you see how as electrons travel from the negative end to the positive end,
Mm-hmm.
it's going to basically cause it's basically going to cause the lithium positive ion to become lithium neutral.
Okay.
And with enough time that you're using this battery, eventually all of the lithium positive ions are going to turn into lithium solid neutral.
Mm-hmm.
So that concentration gradient, that concentration differential, will no
Mm-hmm.
longer exist because it's going to just neutralize it. So that's when the battery is dead.
Mm-hmm.
And that's when you need to plug it into an external source of electrical energy to recreate that ion, that concentration gradient. So it's basically going to use electrical energy to cause a lithium atom that's neutral to turn into a lithium ion again. And then the ions will be more so at the cathode area and less so in the anode area. And then you're going to have that. It's going to be it's going to reestablish the concentration gradient. And then you can use it as a battery again.
Got you. Okay, that makes sense.
Mm-hmm.
So that was it for CP. I only have 3 questions that I still was confused about. I'm getting better with my graph interpretations.
Mm-hmm. Let's see.
Not this one, but the ones that's in passages. So
average relative concentration of ions in pond water and in the cytoplasm of green algae cells. Okay? So black is the pond water, it's basically just low everywhere. In cytoplasm, it's basically higher. Seems to be especially higher for the potassium ion and the chloride ion.
Mm-hmm.
So it seems like the 2+ cations aren't really in a rush to get into the cytoplasm.
Mm-hmm.
Okay, so so basically diffusion and so osmosis, diffusion, and facilitated diffusion, they all don't require energy. Active transport does.
Mm-hmm. So yeah, I know the different definitions for them, but I was confused because if we have a higher concentration of chloride ions in the cytoplasm than the pond water, and it's asking
what
process will move the ions into the cells.
So wouldn't it be from a low so for diffusion and stuff, it's a high concentration to a low concentration, right? But since the pond water has low water. I'm sorry?
I was just saying osmosis is with water from a high concentration to a low concentration. I mean, low concentration to a high concentration.
Well, it's low concentration solute to high concentration solute, but you can think of it as high concentration water to low concentration water. That way, it'll be in line with diffusion and facilitated diffusion, which is high concentration to low concentration. Because basically, if it's high to low, it doesn't require energy. That's true for everything.
Okay.
Now, since there's a higher concentration of chloride or chlorine ions inside the cell than outside, it's moving from low concentration to high concentration, right?
Yes.
So it'll have to be so it can't be any of those other ones, right?
So I was supposed to use this graph, this is what is already here, but if I want to move the chlorine ions
Yeah, yeah.
into the cell, you said it will be from the low concentration of the pond water to the high concentration of.
Mm-hmm.
Okay.
Yeah, low to high requires energy, so that's why it's active transport.
Mm-hmm.
So there's two ways you could do this. Like one way is to note that A, B, and D all are spontaneous, they don't require energy,
Mm-hmm.
and C is the only one that's different. So that's one way of knowing or of getting the answer. Um,
Mm-hmm.
the other way is just knowing, the definition. Basically, it's low concentration to high for active transport, and
Mm-hmm.
they're asking like which process moves chlorine ions into the cells of the green algae, and since the green algae inside of the cell has much much higher concentration of chlorine ion than outside of it, it's low
Mm-hmm.
to high and therefore active transport.
Okay.
So that means it requires like ATP or some type of energy source. And facilitated diffusion is just diffusion but through like a transporter or something. Because that transporter facilitates it. It lets the diffusion happen.
Okay. What did you say about ATP? That's with active transport, right?
Yeah, it'll need an energy source. So one example of an energy source is ATP.
Yeah. Okay. I guess I didn't know what the question was trying to ask me. I was like, you already have what I thought was happening is them asking
Mm-hmm.
it going from, well, I knew the going into the cells from the, I don't know. I just confused it. Okay, low to high. So it's basically asking how the ions got from that low concentration to the high concentration.
Mm-hmm. Yeah, it seems like for any of the ions, it's going to be active transport because there's for every single ion they show on that graph, there's a higher concentration inside of the green algae than outside. So it's going to be the same for everything.
Gotcha. Okay. 37 and 43. So I remember doing terrible on this passage last time, and this time I think I did pretty well. I did 4/7. So yeah.
Okay, let me see.
7/4.
NPY amplified pituitary responses to GnRH, which is gonadotropin releasing hormone. Okay, so GnRH alone causes the blood levels to be 4.74, and when you add the NPY, it goes up to 7.03. So now we're just trying to figure out by what percent has it increased. So that means we're going to find out what percent of so basically we're going to find out like the 4.74, like what percent that is of like the total, which is like GnRH and NPY.
Okay.
Yeah. So you can do that and then add 1 to it, or you can just divide 4.74 into 7.03.
That's what I did, but they did 7.03 into 4.74.
Well, it seems like they did, 7.03 divided by 4.74. So that's 4.74 going in to
Oh, that's what you're saying. Okay.
Yeah, so maybe...
Which one to put as my numerator?
If you put it as your numerator, you would get what percent 4.74 is of 7.03. And then you would have to add 1 to it because it rises from one to the other. So like let's use a different example with easier numbers. So um let's say that GnRH alone is 2, and with NPY it's 4, right?
Mm-hmm.
So you could either do this. You could say, like, what percent is 2 of 4? So you could do 2 divided by 4, which is 1/2, which is
Mm-hmm.
0.5, right?
Mm-hmm.
But since we're raising it by 0.5%, it means that basically it's going to be 1.5. So you could do it either way.
You said since we're raising it to 0.5.
Yeah, so basically, so you could do it like, since they're already asking that it increases it by this percent, you can do
Mm-hmm.
it the way with GnRH alone over GnRH with NPY.
Okay, so
So you could do it
4.74
that way.
divided by 7.03.
Yeah. So let's see. We could do like 4.75 over 7. We could do 5 over 7.
Okay, and so 1 over 7 is 0.13, right?
What's that?
1 over 7 is 0.13.
0.14.
14. So that's 0.70. 5 over 7 is 0.70.
Oh, 5 times 0.14. Um, no, I think it'll be less. I think it'll be like a little. It's gonna be less than. It's gonna be 0.56.
5 times 0.14.
Yeah, because I'm thinking of 14, or I'm just thinking of 15. 15 times 4 is 60.
Because 5 times 4 is 20.
Wait. Sorry, I was doing 4. So
Oh,
4 times.
okay.
Yeah, my bad. So okay, 4 times 0.15 is 0.6. So let's see. Then 5 times that is going to be 0.75. So it's going to be between 0.75 and 0.6.
Okay. But the answer was B.
Okay, let's see.
Because that's what I did, what you just did.
Yeah. Um All right, wait. Let me write this out. So let's see. 4.74 over 7.03. I'm going to just do this. I'm going to do 4 3/4, which is like 4.75, which is equal to 19 over 4 times 1 over 7. 19 over 28. What the hell? .7. All right, so it seems like, okay, so 70%, it's 4.74 is 70% of 7.03. Now, that means it increased by, okay, I think I get it. So 4.74 is 70% of 7.03,
Mm-hmm.
but we're trying to find out by what percent did it increase. So instead of doing 5 over 7, you could do 7 over 5. And then you'll see that it increased by, it seems like around 40%.
Yeah, no, I get the math when they do it. It's just I wouldn't know to set it up this way.
Yeah, the key here is just that they're saying it increased by what percent. So if you go from 4.74 to 7.03, what percent does it increase by? So like let's say that it increased by, if it increased by 2.352, it would have increased by 50%.
Okay.
So yeah, it's really like basically like if I gave you, so if you started off like just to use easier numbers, if it was 5 and 7, and they're
Mm-hmm.
asking by what percent increase is it from 5, if you go to if you go from 5 to 7, it's
Mm-hmm.
basically an increase of like around 40%.
Mm, okay. Yeah, I don't know. That just doesn't make sense to me.
Um so I mean just for yeah, use like a number. So okay, how about this?
No, it's
Let's
not the
say
numbers that's hard for me. It's
yeah.
just knowing to put the 7 in the numerator when
Yeah.
trying to figure out what it amplified by instead of putting, because I put 4.74 in the numerator. That's how I got 67%.
Yeah. No. So I let's. I know you said like it's not the numbers, but just for example, let's say we have 100% of something or 100 of something, and then it goes up to 150, right? So from 100 to 50, what percent does it go up by?
I know that's 50, but
Mm-hmm.
that's still if you knew to set it up by 7.03 divided by 4.74.
Yeah.
But I'm saying before I would know to set it up that way,
Mm-hmm.
I would do 4.74, which is what I did, divided by 7.03.
Yeah.
Okay.
Yeah. So I guess if you are asked something like that in the future, you can take the smaller number and put it into the larger number and see how many times it goes into that, and then it'll be like 1 point something, and you just take that percent that comes after the 1.
Yeah.
Okay.
So this one, since I didn't understand their explanation, it says it's basically this is a frameshift mutation.
Let's see. The precursor of EGP is translated from a transcript that has had one non-templated nucleotide. So if it's a non-template, it means it's the coding strand. So that coding strand has one nucleotide added to the open reading frame. If you have like an addition or a deletion that is
Mhm.
not a factor of 3, it's going to change the reading frame and mess everything up.
Mhm.
All right. So they're saying this change does not create or eliminate a stop codon. If that was the case, it would be like I think a nonsense mutation.
Yeah.
So compared to so I think it'll be like a missense one or something. Let's see. Compared to the protein SGP, which is produced from the unedited transcript, EGP most likely has the same primary. Okay. So it won't be any of the ones that say sequence.
Okay. Why is that?
Because if they add 1 to it and it messes up the like the entire reading frame, its sequence is going to be entirely different.
Okay.
So it'll change the entire sequence, but now we have to see. But will it change like the terminal, like either the amino terminal or the carboxy terminal?
Are you asking me?
Oh no, yeah, no. I'm just saying, it'll just change. It'll keep the terminals, like one of the terminals, most likely the end terminal.
But it says it's the answer was different, carboxy terminal.
Yeah, sorry. So we just have to see if it's going to change. So it makes sense though that like the protein or amino acid sequence that it's going to produce, like there's like one end that's the carboxylic acid end and one end that's the amine group end, and everything within is the sequence itself. So it's going to change the entire sequence within, but it's going to keep one of the terminals. And I think it'll keep the one that's at the end. And I'm trying to remember which terminal is at the end. I should know this, but I'm just gonna look it up. I don't care. So amino acid terminals.
Yeah, it's the C terminal.
It's amine to. Oh, it's N terminal to C terminal.
Yeah.
So it's gonna change the one at the end because the beginning, like the start codon and all that stuff, is the same, but it messes something up after that, and it messes everything up like after that addition, that one nucleotide addition is added.
Okay.
So
the stop codon is outside of the reading frame?
The stop codon, wait, sorry?
Is the stop codon outside of the reading frame?
No. So basically, let's see. So N terminal C terminal. Okay, so I'm going to one sec. All right, I'm going to share my screen really quick.
Okay, let me stop.
All right, do you see my screen?
Mm-hmm.
All right, so for any amino acid, right, you'll have an N terminal, and this thing is like the sequence, and then there's a C terminal at the end.
You said for the amino acid or the...
Oh, like any amino acid chain that is produced when the mRNA is translated, right? It'll produce like various amino acids like along this, right? And there's an N terminal at one end and a C terminal at the other end. All right, so they said a frameshift mutation happened somewhere. Let's say it's right there.
Okay, I'm listening.
So, okay, let's say the frameshift mutation happened here. It's going to mess everything up from this point on. So that's why, like, so this here, this like block that I wrote, that's the sequence. It's gonna mess up the sequence, and it's gonna mess up the thing after the sequence, which is a C terminal.
Mm-hmm.
But it won't mess up what happened before, which is the N terminal, the amino
So where would
terminal.
the stop codon be and the start codon?
Start codon will be like here,
Mm-hmm.
and stop codon will be like there.
So that's why I was confused, because in the question it said this change does not create or eliminate a stop codon.
Yeah, correct.
So if it doesn't change it, then I wouldn't know that the C terminal would change because the stop codon is near the C terminal.
Oh, so basically the thing with the stop codon, if it changes the stop codon, right, that means
Mm-hmm.
that it won't stop. It'll continue going.
Yeah.
But since it
I get.
doesn't change that, the stop codon will still work, but it'll just work like later on.
Okay.
Because let's say the mutation added like a stop codon, then it would have ended here.
Mm-hmm.
But either way, the stop codon part isn't really that important because without the stop codon, it would still mess up everything that happens after. And when I say mess up, like it'll just be different. If it was if the frameshift mutation added a stop codon, it would make this entire thing like shorter.
Mm-hmm.
So basically, like, like that part isn't going to change the fact that any type of frameshift mutation will just mess up anything that happens after.
Okay.
So it'll maintain the N terminal, but it'll mess up everything after.
Okay.
And since I already have this like shared, I can just go over some other things that I wrote in the notebook. So like this is like the example of that question. So in the battery that's attached to like a resistor.
Mm-hmm.
So inside of the battery itself, it's a chemical to electrical change. And then, it shoots, electrons through. And then as it goes through the resistor, it's electrical to thermal.
Okay.
And then this is for half-life. So like 1 over 2 to the n power, where n equals the number of half-lives.
Okay.
And then here's like a machine, like an inclined plane. So let's say that without the inclined plane, right, there's something like a box or something right here on the ground. And you have to raise it up to this height.
Mm-hmm.
So that you have to raise it from here to here, which is distance 1, d1.
Mm-hmm.
Now, for an inclined plane, you're causing it to go in the same, from the ground to up here.
Mm-hmm.
But it's across so it's across d2, this distance. So I wrote delta E, or change in energy, equals delta W, change in work, which is equal to like force 1 times d1, so the force required to raise the box from like the ground here to the height here, so d1,
Mm-hmm.
is equal to the force required to go from here to here, so d2, right?
Mm-hmm.
And if d2 is increased, then f2 must be decreased in order for them to equal each other.
Okay.
So this is an example of like a machine. That means that you don't need to apply as much force
Mm-hmm.
as you would if like F2 is less than F1 if D2 is greater than D1.
Yeah.
And then here I just drew so center of mass must be directly above your feet. So this is like the guy sitting. And you want to either like lean forward. So see how these line up, and I drew this vector, this arrow going down. That's the vector for gravity.
Okay.
And so that's if he leans forward, and this is if he puts his feet underneath the chair. So you see how all these lines are lined up with the vector for gravity.
Mm-hmm.
So you need it to be either this or this. Otherwise, you will create a torque. A torque is just basically when you cause something to like rotate.
Mm-hmm.
So you'll create a torque that will upset the equilibrium, causing you to fall forward or backward. That's what you don't want. You want your center of mass to be directly above your feet. You want everything to be in line with one another. Because if this wasn't the case, if this guy just went straight up, this part over here is not in line with this part. And so this is going to create a torque, so he's going to move backwards. He's going to fall backwards.
Got you.
Yeah.
Okay.
So that's with the center of mass. So,
okay.
Yeah, this is in the new thing that I made for you. So, yeah, that's that. And then here I just kind of did like that thing, but whatever. So, okay, I'll stop now.
Can you rename that AMC full into? Just so I, like...
Yeah.
I won't have a hard time finding. And can you check if you shared it to the right email? Because I still didn't get a notification.
Mm-hmm. Here, I shared it to this right here.
DIA. Yeah, I don't know. I don't know why I haven't received it. Okay.
Okay, you can share your screen again. So that one was the same amino terminal, right? And different. Okay.
Yeah. I don't know if I want to do cars or psych. I feel like maybe psych. What's definitions? What? Should I just go through the wrong ones?
Oh, sure.
I don't know. Let me. It's just a long passage. Okay.
All right. So, unfortunately for cars, I may not be able to answer it without reading it, but let me see. Suppose that rigorous. Rigorous. Did you have more than one question wrong on this passage? Let's see.
No.
Okay, just that one. Let's see if there's a passage where you have more than one wrong. Just because with cars, I think I need to read the entire passage. Let's see. This one. That's 2, 3.
I did bad on this one.
Okay.
Oop. Okay.
All right, so let's see. People must sometimes perform skillfully on difficult tasks before an audience. Under such circumstances, they often wish to have friends, relatives, or other supporters present. It's worth asking whether a supportive audience is really helpful. I think I remember this. Okay. Or whether it might not instead impair the performance. Previous research shows that the effect of audience support is not simple or uniform. The following study was designed to test competing hypotheses about the effect of a supportive audience on performance, okay? Because friends are the most common source of social support, experiment 1 compared the effects of observation by a friend and by a stranger during the performance of a task that previous research had shown to be stressful, okay? Task was to count backwards aloud by 13s, starting from 1470. Participants were told that their goal was to perform the successive subtraction operations as quickly and accurately as possible during a 2-minute trial. At this point, in the instructions, the experimenter indicated a one-way mirror and a microphone telling half of the participants that a friend who had accompanied them to the testing room would observe their performance. The experimenter mentioned a fictitious name to the other participants as their observer, aka the stranger, okay? Now, the results suggest that a supportive audience actually has a detrimental effect. So the opposite of what people thought. The participants who believed that a friend was watching them made a significantly higher percentage of errors than did those who believed that a stranger was watching them. Yet the number of errors made at particular stages of the performance, for example, the second subtraction, was almost identical in the two conditions. The decrement in the supportive audience condition resulted from a slower rate of responding, which meant that the neutral audience condition produced more responses with increasing accuracy on the later ones. Okay, so it seems like when they had a supportive audience, they just went slower, and that resulted in them not having a better overall effect. Okay. The participants' answers to post-experimental questions indicated that they were not aware of the effect of the observer on their performance. In fact, participants in the supportive audience condition were less likely than those of the neutral audience condition to support being distracted by the observer or feeling stressed while doing the task. All right, furthermore, the negative effect of a supportive audience is apparently not due to discomfort about being judged. The participants' ratings of their feelings of being evaluated were nearly identical in the two conditions. Okay, so that's telling us that after the experiment, they asked the participants questions, and they basically said that when they had friends observing them, they were less distracted or stressed. So even though they have even though they did worse on the experiment when they had friends observing them, they did not feel like they were more stressed or that they were distracted. Okay. The researcher concluded that supportive observers impair the performance of a difficult skill-based task by promoting a response style that reduces speed without increasing accuracy. Still, the reason for this audience effect is unclear. Friends and strangers differ in many ways, including their knowledge of one's abilities, their desire to witness one's success, and their expectations about one's behavior in a particular situation. Alright, in experiment 2, all of the observers were strangers, and their supposed supportiveness was manipulated. The experimenter told participants in the supportive audience condition that both they and their observer would receive a cash prize if their speed and accuracy surpassed a certain criterion. Participants in the neutral audience condition were told that they alone were to receive the prize for a good score. They thus had no reason to suppose that the observer cared about the quality of their performance. Experiment 2 confirmed the prediction that a skilled performance would suffer with a supportive audience. So that's true for experiment 2 as well. Other questions remain. Did the difficulty of the task produce an expectation of failure that impeded its performance? Is a supportive audience a special case of an especially attentive audience, or one likely to respond emotionally to a performance? And why did performers report feeling less distracted by a friend than by a stranger when their performance suggested the opposite effect? Okay.
I'm still trying to find this notebook.
What is the most likely explanation of the slower rate of performance observed in experiment 1? Alright, let's see. Desire to maintain an appearance of relaxed competence before friends, a feeling of being judged more harshly by friends than by strangers, an inability to concentrate on mental tasks when friends are present, a belief that accuracy is more important than speed on certain tasks. Okay, so tell me what made you, or like what are you thinking about this? Like what made you like cross out B and C?
So, yes, I was between A and B. I chose A first, and I switched my answer because when I went back to the passage, it said that they aren't afraid of being judged or something like that. Where is it? Yeah. Furthermore, the negative effects of a supportive audience is apparently not due to discomfort about being judged. So I was like, they wouldn't care to be like relaxed or competent before their friends because they're not afraid of them judging them.
Well, I mean, that seems like it's choice B, where they're talking about feeling of being judged.
Yeah, no, that's why I crossed,
Yeah.
I was like, A, B, and C are all talking about being judged.
All right, let's see. So A is saying a desire to maintain an appearance of relaxed competence before friends, and D is saying a belief that accuracy is more important than speed on certain tasks. Okay, so it seems like when they had the supportive audience, it seems like they did a response style that reduces speed without increasing accuracy.
Mm-hmm.
So so if they're reducing speed without increasing accuracy, it would lead me to believe that D would not necessarily work because D is saying that they believe that accuracy is more important than speed. So wouldn't that lead to them being more accurate?
Then I highlighted that. Okay.
I want to see what their explanation is for D. Quickly and accurately as possible. Neither quickness nor accuracy was prioritized, so this option is not supported in the passage.
Mm-hmm. Okay.
So I guess they're saying that in paragraph 2, where it says like the instructions are to answer quickly and accurately as possible, they're saying that both speed and accuracy are important. So if they're told that both speed and accuracy are important, then I don't know if they would believe that one is more important than the other. But
Okay.
but if you like think about, because they're saying like most likely explanation for them being slower when they're think that their friends are watching, it could be to maintain an appearance of relaxed competence because they maybe feel like um, maybe they don't feel like as like motivated, or since maybe it could be due to like them feeling that strangers would like, I don't know, maybe they just feel that like a stranger would care more about how fast they answer, but if they're around friends and friends are watching, then they can kind of be like, no, I'm cool, like, I'm not like letting this get to me, so I'm just going to be relaxed and still competent. So yeah, this one is pretty tough. I would just say that D wouldn't be it, just because like the instructions didn't say to that
Yeah,
one is more important.
I crossed out B and C. I knew those two wouldn't be it.
Oh, I mean D.
Oh, okay.
Like it's kind of difficult, but I would only not choose D because their instructions tell them that both speed and accuracy are important. So one is not more important than the other, and also the fact that they did not improve their accuracy if they reduce their speed.
Mm-hmm.
But overall, it's pretty tough because they're kind of asking you to come up with an explanation for this weird kind of phenomenon.
Yeah.
So A is kind of like, it's like whatever. I guess this is like reasoning beyond the text or something.
Probably. This one.
What finding from other research would be most apt to raise questions about the conclusions supported or reported in the passage? Okay, so if
Wait, what did I put? I put D.
so they're saying like if this is true, what would, like, when it says raise questions, it basically means what would
Yeah.
weaken.
Yeah, I read this wrong. Because
Um,
I get why it's B, because they said that the
oh yeah, B is like the opposite of the findings that they found, right? They
Yep.
found that when a friend is present, they perform less skillfully.
Yep. Okay, yeah, I read that wrong. Is this the same? Yeah, same passage. And I picked B. Okay.
In experiment 1, which of the following hypotheses would most reasonably account for the post-experimental statements made by those in the neutral condition? All right, in the neutral audience condition, they were less likely to report being distracted by the observer. Oh, no. Wait. Sorry. No. The neutral audience condition reported being distracted more. Because they're saying supportive audience were less likely than the neutral audience condition to report being distracted or feeling stress. So that means the neutral audience had or reported being distracted more and feeling stress more.
But they still performed better.
Yeah. So that kind of makes me think that stress can help you on these guild tasks or whatever. So let's see. What could account for that? A performer's anxiety need not adversely affect performance. Performer's anxiety can be reduced with no effect on performance. An audience can affect performance by reducing performance anxiety. All right, so A is saying that anxiety does not need to negatively affect performance.
Yeah. I don't know if I went through these last two questions really fast.
Mm-hmm.
I don't know, but I get why it's that.
Mm-hmm.
Okay, honestly, we can do psych-social because, I can go over this by myself maybe.
I'll be right back.
Okay, so for this one, the reason why I chose A is because they said that they don't perceive color categorically. So that's why I chose A.
Which graph best describes the Baboon data for the color matching test? Okay, let me see the passage. Oh, let me see the passage. All right, so okay, those are for people. Let's see. Wait, what? Hold on. It says that figure 1 is for English speakers, so those are humans.
Mm-hmm.
Where does the baboon testing come? Oh,
There's
okay.
some-
The study was designed to examine color perception of baboons. Their visual symbols system resembles that of humans. Okay. Color mask. Okay, target color. Okay. I see. So basically, they're saying that. So figure 1 shows that how humans answer to the question. So basically, they're only given 2 choices: blue, basically, or green. But they're given basically they're given all the colors, like all the shades.
Mm-hmm.
So basically, that's showing that humans, despite being a continuum of things that are let's say blue and green are 2 particular colors, when given a continuum of things that are close to blue, the humans will answer that it's blue, like focal blue, right?
Mm-hmm.
And if it's a bunch of colors that look like green or are closer to green than blue, they still say green. So humans view it categorically. Like if a color is closer to blue than to green, they're going to answer blue.
Okay.
But for baboons, it says the results indicated that although baboons can discriminate color successfully, so the baboons can still see the same colors we do, they do not perceive it categorically. So they're not going to say if it's close to looking like blue, that it's blue.
Mm-hmm.
So there's not going to be... So you see how there's an abrupt change in figure 1? So that abrupt change means that... So from 475 to 495, we humans say that it's focal blue.
Mm-hmm.
So that's why the percent of green responses are so low. And then from 500 to 515, humans say that it's focal green. So that's why it's an abrupt shift to 90% or higher of green responses. So that means humans view it categorically, right? We view blue as a category under which different shades can exist. Baboons do not. So we're going to see much more gradual or continuous kind of responses instead of something that abruptly shifts.
Okay, so yeah, I knew it wouldn't be B or C, but then I ended up choosing A.
Okay, so you're good in not choosing B or C because A and D are both are not categorical.
Mm-hmm. But I guess because the percent of it is at the same.
Yeah, because that kind of shows that the baboons can't perceive color well. Because if they think that everything, if it's close to blue, is the same as if it's close to green, whereas D shows that, yes, if it's closer to blue, they're going to be less likely to pick green, but it's continuous. It's not an abrupt shift.
Okay.
So there's no categories there.
Okay.
So in the first sentence it says color is a continuous variable that humans perceive categorically. So we don't perceive it we don't perceive it continuously. So that's why there's this abrupt shift.
Okay. And for this one, so when I saw cortisol, I was thinking about stress hormone. Huh?
Cortical activity?
Yeah. Mm-hmm. I mean, not cortisol. When I saw cortical activity, I was thinking about cortisol.
Mm-hmm.
So I was thinking about stress. I was thinking about sympathetic, fight or flight.
Yeah. So cortical just means cortex, which is the outer portion of something. So like,
It said as they viewed the color patches. Okay, I know why I
yes.
got this wrong. Because I know
So
occipital is vision,
mhm.
temporal is hearing, motor is movement.
Yeah. So cortex, just link that to, it means outer portion. So that's why there's cerebral cortex. It's the outer portion of the brain, right? Not like
Mhm.
deep inside. Adrenal. There's an adrenal medulla, an
And a
adrenal
cortex.
cortex, right? Cortex is the outer portion. In the
Mhm.
kidneys, there's also like the medulla and the cortex. Cortex is the outer portion. I think you kind of froze, or are you? Can you hear me?